Yes. Say again. I've not put the quiz grades in. No, not yet. I will be though, probably by the end of the day today or so. Okay. All right. So anywho, back to what we were talking about here. All right. Dilations is what we're going to be looking at today, or dilations are what we're going to be looking at today. And the essential question we want to answer is, how does a dilation transform a figure? Okay. So if you guys would actually, I would like you to go ahead and take your protractors that I gave you there and measure the sides of triangle ABC, and then put those measurements right there. And then also measure the sides of A prime, B prime, C prime, and put those measurements here. Please measure to the nearest tenth of a centimeter. Tenth of a centimeter. Okay, and then letter B, use a protractor to measure the angles too. Okay, you may need to extend some of the sides in order to get it to work. Oh my gosh. Sorry. All right. So again, let's get those measurements down. So angles and sides. Angles and sides, please. And I will do the same. And then if you want, you can also complete the ratios for letter C as well. And then if you want to answer some of the questions at the bottom there. So again, basically just complete this side of the page here, page 577. Okay, and answer those questions as best you can. questions to the bottom, with 1 and 2 at the bottom, once you get everything. You can answer the whole page there if you can, once you got the measurements and stuff down. Alright. Fill in that page there at the bottom. One more minute. Yes, Madison. Like you measure this angle? So you just have to use the protractor, you mean? So it's, well, it's kind of hard to, well, I'll do it this way. So, you want to line up the little crosshairs there, and then line up this kind of like side too. And so then this side of your angle right here, that's 0 degrees. And so, oh, I see what you're saying. Actually, here we should measure this way because the angle I'm measuring here. It's the way I set it up right there. I'm actually going to end up measuring this angle, which is not what's wrong with this angle. So you could, well, what you could do is you could measure, this angle and then subtract from 180. That's one option. But if you want to do it this, you can go here, that side. So now I'm going that way. Okay. And so yeah, you kind of extend it. It's kind of hard to see here. These are pencil. So like 35 maybe, I would say. Because again, you want to use this because why? Because this is our starting side of our angle, which we want to start at 0. So we use the inner set of numbers. Okay. Does that help a little bit now? Okay, yeah. I know it's been a while since we used it. That's why I figured it would be a good practice to get into there. Okay. Okay, so here are my measurements. All right, hopefully you got something close to mine. All right, it might be slightly different just depending, on, just how you set up your protractor, especially those degree measures. Okay, so don't fret too much. Hopefully A, yours are very close to mine. Okay, but B, don't fret too much if you're again just having some trouble with those degree measures. All right, certainly what we would expect. Well, actually, we'll come back to that there. I'll come back to that idea first. Okay. So of course, hopefully when we were able to set up our ratios here, A prime, B prime to AB was 3 to 6 in my case, so I got 1/2. A prime, C prime to AC was 2 to 4, and then B prime, C prime to BC was 1.5 to 3, which all of those simplified to 1/2. All right. So, what do we notice about the corresponding sides of the figures? So corresponding sides, right, we match them up. AB matched to A prime, B prime, AC to A prime, C prime, BC to B prime, C prime. What do we notice about the corresponding sides of the figures? How are they related? In this dilation here, how are they related? See? The ratios are 1/2. That's right. Okay. And what about the corresponding angles? How are they related? How does A compare to A prime? How does angle B compare to angle B prime? How does angle C compare to angle C prime? How are they related? They are what? They're equal, or they're congruent. Exactly right. So corresponding sides, I'm going to say just as a general rule, are proportional. Okay, corresponding angles are congruent. Okay, which again should come as no surprise, just because, well, the nature of our problems here. All right, I know this might upset some folks here, but so you can see the screen a little better. All right, sorry. Of course, if you're a vampire, you're welcome. All right, so anyway, number 2, what similarities are there between reflections, translations, rotations, and dilations? What is the difference? Okay, so going back to talking about what we did with reflections, translations, rotations, okay, and dilations, what are some similarities between these transformations? What are some similarities between these transformations? What, is still the same, Madison?
The angles are all the same.
Okay, so a similarity, angles are, well, I should say corresponding angles. I'm going to abbreviate that here. CORR. Corresponding angles are congruent. Okay. Is that the only similarity between dilations and reflections, translations, rotations? They just have corresponding angles that are congruent?
They can be the same shape.
Yeah, the shape stays the same, right? Okay. Same shape. Okay. The one other thing I'll say too, we could also say, or sorry, let me ask you this way. Could we also say that the ratios of corresponding sides are proportional? So it's true for similarity, or sorry, it's true for dilations, right? We just saw that the ratios of corresponding sides are, proportional. But is it true? Is it still true? Are ratios of corresponding sides still proportional for reflections, translations, and rotations? And if so, what's the ratio going to be always?
1.
Yeah, 1-to-1, right? Because we're matching something to its exact copy in reflections, translations, rotations, but they would still be proportional. So corresponding sides are proportional. Okay. So you can even think of reflections, translations, and rotations as being similarity transformations, okay? But their ratios will always be a ratio of 1-to-1. All right, differences. Okay. So what's the main difference between dilations and reflections, rotations, and translations? What's the main difference? Madison, go ahead.
The sides are equal.
Yeah, the sides are not, corresponding sides are not equal. So again, I'm just going to abbreviate corresponding as CORR. Corresponding sides are not equal in dilations. Generally speaking. We can talk about dilating a shape by a scale factor of 1, but in general, dilations will not be the same size, okay, as each other. All right, so let's actually talk about doing a dilation here. We're going to do one, okay? We're going to dilate a segment. So if you turn the page, and I'm actually going to tear these pages out because it's hard to do this. If you don't want to tear your pages out, that's fine. But I'm going to tear mine out because it's a little bit easier to do this. All right, we're going to do a dilation here, and we're not going to use a compass. All right, so we're going to kind of like do what I would call like a construction, I guess. We're not going to use a compass. We're just going to use our protractors. Okay, we could use a compass here to do this, but we're not going to, just because, I don't know, save some time. All right, so we're going to dilate a line segment here, AC. Okay, so that's the pre-image or original. And we're going to dilate this one, in this case, by a scale factor of 3. So apply a dilation by a factor of 3 with center at the point O. Okay, and we're going to dilate that AC there. So point O is our center of dilation. Point O is our center of dilation. You always, when you dilate, you need a center of dilation. Okay, about which you are like kind of dilating from. We're dilating out from that central point O. Okay, so to do this, we're going to locate the point A prime. Okay, and to do that, we're going to draw a ray from O through A. So a ray, remember, starts at a certain point and goes through A infinite in the direction of A. There, like that. Okay, if you want to put a little arrow at the end for it to be like seen as a ray, there it is. And they're going to find A prime on this ray so that the distance from O to A prime is 3 times the distance from O to A. So let's measure the distance from O to A there. Let's measure that distance. Okay. I get it to be about 1 centimeter there. You guys okay with saying that's 1 centimeter? Okay, let's call that 1 centimeter. So let's say from right here to here is 1 centimeter. From O to A. So then the distance from O to A prime, if we're going to use a scale factor of 3, what's the distance from O to A prime going to be? 3, right? So we're going to go 3 centimeters out from O along that ray, and then we'll say there's A prime. Okay. We'll do the same thing for O to B. So we'll draw our ray from O through B. All right, we'll measure from O to B. All right, in this case, I don't quite get that. I might call that like 0.9 centimeters maybe. Okay. So 0.9 times 3, 2.7. Okay? And we're going to measure 2.7 from O again. Don't forget, that center of dilation, that's where we measure from. So 2.7, so 0.567. Okay. We'll call that B prime. And we'll do the same thing for C. Okay, O to C, we'll measure that. From O to C, let's see here. I get it to be about 1.3, I'll say. Okay, so 3 times 1.3, 3.9. 3.9. Okay. And then if we connect A prime, B prime, and C prime, we should have our dilated line segment. Alrighty. So there's our dilated line segment. Now, how do you think the length of A prime C prime compares to the length of AC? What do you think? How do you think the length of A prime C prime is going to compare to the length of AC? The segment AC there. What do you think? How will they compare? Or will they compare? How will the length of A prime to C prime compare to the length of AC? Or how should they compare maybe? Maddie G? Okay, proportional. What will the proportion, like what will the actual value be? So for example, if the length, let's just say hypothetically, if the length from A to C was 2 centimeters, what would you say A prime C prime's length would be? 6. 6 centimeters, yeah, 3 times as much, right? Scale factor is 6. Very good. If we were to extend AC so that it was a line, So if we were talking about line AC, if it like extended forever in both directions, and if we were to talk about a line A prime C prime, how would those two lines relate to each other? What might be the relationship between those two lines? So again, if AC was extended to be a line and A prime C prime was extended to be a line, how would those two lines relate to each other? What might we say would be true about those two lines? They'll be parallel. Exactly right. Okay. When you dilate a segment, okay, like this way, the lines, they're parallel to each other. The segments, or you could even say, are parallel to one another. Yeah, so these are, I'll maybe mark that here. Maybe do that in red so that way it stands out. Okay, so yes, these two little line segments here are parallel to one another as well. Okay. Let's check to see if the segments are in fact 3 times as long here. So here I get about, I don't know, like 1.6, 1.7, something like that. So around like, okay. So then 3 times 1.6 or 1.7, okay, should be about 4.8 or 5.1. So we expect A prime C prime to be between 4.8 and 5.1, and sure enough, it is, right? It goes to about like 4.9 or 5 centimeters there. Okay, so it does kind of fit in between there. Okay, so it is roughly 3 times as long. All right. So a factor of 3 took our AC and made it bigger by a factor of 3, right? It multiplied it by a factor of 3, okay? You'll notice here that the distance of each point from the center of dilation, okay, the distance from each point in the original to the center of dilation, you then multiply that by the factor to then get out to those other points there, okay? So it's, if the original point was 1 centimeter from O, the image would be 3 centimeters from O. If the original was 0.9 from, if B was 0.9 from O, then its image would be 0.9 times 3, 2.7 away. And then 1.3 C is away, then 3 times that, 3.9 away from that center of dilation. Okay? All right. So let's take a look here and reflect on this then. So make a conjecture about the length of the image of a 4 centimeter segment after a dilation with a scale factor K. So if we start with a segment that's 4 centimeters long and we dilate it with a scale factor of K, what will its new length be? Or what would the expression for its new length be? What do we say? If we start with a segment that's 4 centimeters long, and we dilate it with the scale factor of K, what would be the expression for the length of that image, the new segment there? What would it be? Avery?
4 times.
Yeah, 4 times K. Okay, so 4 times K. Can the image ever be shorter than the pre-image? What do you think about that? Can an image, when you've transformed something, when you've dilated something, can it be shorter than the pre-image? And if so, how would that happen? What would be the case? How can we make something shorter? Right here, we dilated by a scale factor of 3. We took AC, we made it longer. Right? Can we make it shorter?
A fraction.
A fraction. What kind of fraction, though? Right, because like 5/3 is a fraction still. So can you,
A fraction less than 1.
there you go. A fraction that's greater than 0, but less than 1. Actually, between -1 and 1, I guess I could say there. So yes, if the scale factor is between 0 and 1, okay, the image will be shorter or smaller. Okay? So, what can we say about the image of a segment under a dilation? Does your answer depend on the location of the segment? Well, we could say that a dilated segment, a dilated segment was parallel, or is parallel, to the original segment. Okay. There is one case where a dilated segment will not be parallel to its original segment. There will be one case here where a dilated segment will not be parallel to its original. Remember, parallel lines never intersect, right? So there is a case where a dilated segment will not be parallel to its original or pre-image shape there. Can anyone think about what that case would be? Avery?
When dilated by a scale factor of 1.
Dilated by a scale factor of 1. Okay, so maybe I should say there are two situations. But yeah, dilated by a scale factor of 1, absolutely, absolutely. What if we took our segment here, ABC, and instead of dilating it about point O, what if we dilated about point B? If we dilated from point B, then it would just be A and C that would be still going in the same direction. They would just go further away from B, but in the same direction as AC are currently going, right? So it would dilate, it would stay where it was, it would just stretch it out, the length of it basically. And so if your center of dilation is on your object, okay, then in that case, or on your line, then in that case the two lines won't be parallel still. Okay, so if your segment is on the center of dilation, then you won't be parallel because it'll be on top of one another still. Okay, all right. Let's take a look then for these properties of dilations. All right, so the next page there. So properties of dilations. Okay, the center of dilation is the fixed point about which all other points are transformed by a dilation. Okay, the ratio of the lengths of corresponding sides in the image and the pre-image is called the scale factor. This is crucial here, so I want to make sure I highlight this. Okay, the ratio of the lengths of corresponding sides in the image and the pre-image is called the scale factor, or put more shortly, the scale factor is equal to the ratio of the image to the pre-image. Okay? The image to the pre-image. So we go back to our example here, right? C prime was 3.9 units away. Divide that, so that's the image distance from O to C prime. The distance from O to C was 1.3. So to come up with the scale factor, you would take the distance from O to C prime, 3.9, the image distance, and divide it by the original distance, 1.3. Okay, image divided by original or pre-image there to get that scale factor. Okay, if you don't get the order right, you're going to have your scale factor be wrong. It'll be the reciprocal of what it's supposed to be. All right, properties of dilations. Dilations preserve angle measure. We knew that, right? Dilations preserve betweenness. Betweenness. Okay, that means if you pick a point here between A and B, and if you dilate this shape, then that point will still be between A and B, right, in its image. Dilations preserve collinearity, so again, if things are on the same line, then they'll still be on the same line after you dilate it. Dilations preserve orientation, okay, orientation. So the order of the points as you go around it will still stay the same, which is different than like a reflection rotation. Dilations map a line segment, the pre-image, to another line segment whose length is the product of the scale factor and the length of the pre-image, right? So you just multiply the length of the segment by the scale factor, and that gets you your new line segment. And then dilations map a line not passing through the center of dilation to a parallel line and leave a line passing through the center unchanged, right? And again, we just talked about that. Okay. If you dilate a line with the center of dilation, then your image will be parallel to it, unless the line goes through the center of dilation, in which case it's the same line. All right, so let's take a look here. Letter A, right? Okay, you can see here, determine if the transformation on the coordinate plane is a dilation. If it is, give the scale factor. Is this a dilation? No, very clearly not, right? What kind of transformation is this? It's a reflection, right? So a reflection is not a dilation, so no, okay? And in this case, one of the arguments you can give, it doesn't preserve orientation, right? If you go around counterclockwise here, it goes A, B, C, D. But if you go around counterclockwise here, starting at A prime, it goes A prime, D prime, C prime, B prime, right? Going counterclockwise here, A, B, C, D. Here, A prime, D prime. So it's wrong order. Okay, let's look at letter B. Okay, does it look like in letter B that we preserve angle measures here? Yeah, it does, right? It looks like it preserves angle measures there. Okay, so we'll say, yeah, that's fine. Okay, does it look like it preserves betweenness of points? I guess so, yeah. I mean, that's kind of hard to see, but we'll say so. Does it preserve collinearity? Are things that start on the same line, do they end up on the same line still? I say so, yeah. Okay, does it preserve orientation? A, B, C, A prime, B prime, C prime? Yes. Okay. What's our scale factor, though, then? So if these are, in fact, going to be similar, we got to be able to figure out what the scale factor is. So, what's our scale factor going to be? You have to figure that out. All right, Avery, you want to give it a try? What do you think the scale factor is going to be here, Avery?
Well, I figured it out beforehand that it was 2, and
How?
well, I just sort of did it by counting, like I counted how many squares it took up, like what the slope would be, and I.
So like from A to B?
Yeah, and then it preserved the slope, and it also like it took up twice as many squares.
Okay, so that's one way to kind of think about it. Okay, so from A to B, we had to go up 1, right 3. To get from A prime, B prime, we went up 1, right 3, up 1, right 3 twice. And so Avery's like, aha, since it took 2 times as many times, the scale factor must be 2. And she's right. That's one way to do it. Okay, you might run into some issues with that. You know, if the slopes don't, if the points don't line up on like nice coordinates and stuff. Another way we could do it. Okay, if you remember what Stephen had us do earlier during the warm up, right? He took the point like C in the warm up and then transformed it to C prime using the transformation. Well, let's take a look at the coordinate for C here. C has coordinates 0, 2. C prime has the coordinates 0, 4. Well, how do we get from 2 to 4? Multiply by 2, right? Multiply by 2. So there's another way to get that scale factor. Okay, you can take the image's y-coordinate and divide by the original or pre-image's y-coordinate. So 4 divided by 2 gives you that 2 there. Another way to do it. Okay, but Avery is exactly right too. So is this transformation dilation? Mm-hmm. Yes. All right. So let's flip it over here and take a look. Why don't you guys go ahead, try 5 and 6. Determine if those are dilations. And if they are dilations, identify the scale factor. Okay? You don't need to run through all these yes/no questions if you don't want to, but do take the time to look and see if you think they are in fact dilations. So 5 and 6, go ahead and identify whether they are or they are not. If they are a dilation, or if it is a dilation, give me the scale factor, please. Okay? Give you like 30 more seconds here. 30 more seconds. 30 more seconds. So, Caroline, number 5 there. Were you able to determine if it was a dilation or not?
No.
You weren't sure? Okay. So, what did you look at?
What are the distances between the angles?
Okay, and so you some of those are hard to find, right? Because they're diagonal and stuff like that. Okay, so it turns out that these shapes are in fact a dilation. I'm glad that you were checking the all the different lengths and stuff like that. But it actually turns out that they are a dilation here. Okay, it is a dilation. I'll say they are a dilation of one or the other there. Okay, and the scale factor is going to be 3/2. Okay, now you're right. I did not go through and check all the sides either because that just would have been a lot of work, right? So I just went ahead and just checked C and C prime to D prime there. And kind of went from that. Okay. One way you kind of convince yourself here too, Caroline, without having to go through all those calculations of whether the distances match up, right, is you can also use the slopes to help you too. Okay. If you look here, for example, right, from C to B, it goes up 2, right 2. From C prime to B prime, which is a slope of 1, really, right? From C prime to B prime, it's up 3, right 3, also a slope of 1. So they're parallel, so that's good. And then if you keep going around, all these other segments are parallel to one another, like their pre-image and their image. And so that's going to indicate that all the angles then between those sides will be congruent. And so therefore the shapes will be similar because all their angles will match up. Okay? And so we have that ratio. All right? And then the 3 and the 2, well, that's easy enough if you just pick a nice pair of sides. For example, the CD and C prime D prime. C prime D prime is 3 over the 2 for CD. So that makes it easy to get then the ratio. Okay, so does that help some? All right. And then number 6, well, I guess I'll go ahead and just show it to you there. 6 we would say is not a dilation. Okay, you can say a couple different things here. I just said the orientation changed, right? If you go A, B, C here, that's a counterclockwise direction. If you go counterclockwise here, it goes A prime to C prime, then to B prime. Okay, so it's just the orientation's off. The order of the points is different. Okay, so let's now talk about dilating and finding the center and scale factor, okay, of that dilation. So here, for example, 2, we're asked to determine the center of dilation and the scale factor of the dilation of the triangles. So in order to find the center of dilation, super simple. You just draw the lines connecting the point and its image, point and image, and they'll all intersect back at the center of dilation. Super convenient there. And then as far as finding the scale factor, you have some options, okay? So their suggestion here is to measure the distance from the center of dilation to the original point, and then the center of dilation to the image. So O to A prime, O to B prime, O to C prime. Okay, and get those lengths, and then do the ratio of the image distance divided by the original. So image 50 divided by original 25, 26 divided by 13, or 38 divided by 19, and all those are 2 to 1. Okay, 26 divided by 13, and then 38 divided by 19. All equal 2. Or 2 over 1. Are there other measurements we could have done here to find that same scale factor besides the ones that they did? What else could we have measured here besides what they measured in order to get that same scale factor? What other way could we have gotten that scale factor there? Any ideas? How you can find that other scale factor? Or any other ways to find a scale factor besides using the distances from the... Yeah, the length of the segments, exactly right. So, we could have done C prime to B, C prime B prime over CB, or A prime C prime over AC, or A prime B prime over AB. That also would have worked too. You would have gotten 2 as well. Okay, very good. Well, let's keep going here. All right, so let's try one here on our own. All right, so let's find that center of dilation. So again, ruler or straight edge there. We're going to just draw a line from A through A prime. Okay, like so. And then we'll do B through B prime. Okay. And then do I need to do C through C prime? Well, not really, but let's just do it just in case. But we better end up in the same spot there. Ooh, it's looking a little off. Not bad. Okay, so there's our center of dilation where all those lines intersect. That's we'll call that O. Okay. And so then we can figure out the scale factor here. So I'm going to measure using millimeters, okay? And I'll just do one measurement here. We don't need to do measurements, all these measurements. So I'll find the distance from O to A. I get that to be about 6, I think. And then from O to A prime, I get that to be about 3. Okay? So what's our scale factor here? It's not 2. 1/2. 1/2. Yeah, be careful. It's image over original. So in this case, it's 1/2. Okay? And we can also kind of convince ourselves it's got to be a fraction, like Jackson said earlier, right? We were taking our original here, we're making it smaller. So it's got to be something less than 1. Okay, because of that. All right, questions on any of that? That's how we can find the scale. Again, you can do all sorts of things. You could do, O to B and then O to B prime, O to C prime. You can also measure AC and A prime, C prime, like Emma suggested. Okay, so lots of options there. Okay, and that's it. So let me get you guys started on your assignment then. Okay. So for your assignment here, let me get myself organized and then I'll get you started. I think I would like you to do goodness. You want to do that? Okay. 2 through 19, starting on page 582. But you can skip number 13. Okay, skip number 13. But I think I want you to try all the other ones there. Yep. Don't forget, you also have your 10 marks assignment that's due this evening, so you can finish that up tonight too. Okay, we'll get you another one assigned here, ready to go for next week too. Okay. Yes.